why is the conjugate even helping us out here? What is so magical about it? Because it really is quite beautiful, isn't it? Heyo, it's Mr. Otwell, the Math Master, helping you master math. And in this video, we'll be dividing radical expressions by using the conjugate. This video is going to help you when you have two terms in the denominator and one of them has a square root. How do we get rid of those? Make sure to like and subscribe and comment. Let's do this. So here we have another type where in the denominator, there's no longer just one term. We have two terms. We have to deal with these a little differently because we need to get rid of the square root. But if you think about our old method, if we multiply by our clever form of 1 here with the square root of 11 on the top and the bottom, we distribute the top as 2 square root of 11. Remember, with one term, you got to distribute this too. So we distribute the square root of 11 to 3 and you get 3 square root of 11. And we do our square root of 11 times square root of 11, which is good because that gets rid of that radical, but we just made another one. So our method from before doesn't quite work. If we have two terms in the denominator, we can't just figure out what that square root is, multiply by it, because it doesn't simplify it. So what to do? How can we figure this out? Well, there's this amazing thing. You may have heard of it. It's called the conjugate. We utilize it in complex numbers and really in rationalizing the denominator. That's the most common places you'll see it. We want to multiply this expression by this guy's conjugate. Now, what is a conjugate? I'll show you. It's right here. Are you ready for this? Hey, there it is. So, the conjugate of a binomial. So remember, a binomial is an expression with two terms. So 1, 2, there's two terms there. The conjugate is when those terms remain the same values, but take a look what happened there. Take a look what happened there. It flipped from positive to negative. You're going to change that sign in the middle. And in the same way, if you just had something minus something else, the conjugate of that binomial would be that plus the other thing, right? All we're going to do here is we're going to keep those values the same and flip the sign. So let's just go ahead and multiply by it and see what happens. It's pretty exciting. So we want to multiply by the denominator's conjugate. What is the conjugate? Remember, we're going to keep the values of the first term and the second term the exact same. So this is a 3. We want to keep a 3 right here. This is the square root of 11. We want to keep the square root of 11 there. What do we got to change? We have to change from a positive to a negative. So we're going to throw a little minus sign right there. This expression is the conjugate of this one. If you have a binomial, if you have two terms, and you flip the sign in the middle and that's all you do, that's called the conjugate. But can you just multiply that in the denominator? Is that okay? No. We have to multiply by a clever form of 1. So let's do that. If we have 3 minus the square root of 11 in the denominator, we also need the exact same thing in the numerator because anything divided by itself is just 1. So what we're doing here is we're just multiplying by a clever form of 1. So if you take a look at step 1 over here, I've kind of written out the rules, kind of those steps. If you see more than one term in the denominator, you want to simplify any square root in the denominator if it's actually possible. In this case, you can't simplify a square root of 11, so it's not going to help you out. Then we're going to multiply by a clever form of 1 using the conjugate, and we've already discussed that. This is so important, okay? Make sure that when you distribute, you're super careful. You need to make sure you're watching those negatives. But right now, you might not even be seeing what distribution are you talking about. Well, it's helpful, just like in that last example, if you have more than one term in the fraction, I actually like to show that grouping with some parentheses because that gives you that visual cue, hey, I'm going to have to distribute some stuff. Because check it, we're multiplying two fractions here, so we're multiplying across, right? We have 2 times all that. So when we have a 2 outside the parentheses, we need to distribute the 2 to both terms, So 2 times 3 would get us 6. One thing I like to do first before distributing to more terms is just check my sign. I've got a positive times a negative. So that's going to give me a negative. Please make sure you need to keep track of your negatives. Stuff can get messy here. Positive times a negative gives me a negative. And then 2 times square root of 11 is just 2 square root of 11. 2 isn't under the square root, so we can't combine it or anything. And we can't simplify that anymore. So our numerator is 6 minus 2 square root of 11. But check our denominator out. Look, we have 2 terms times 2 terms. So we need to distribute again. We need to distribute this 3 times this 3 and times the negative square root of 11. So positive times a positive gives us a positive, and then 3 times 3 is 9. Now check it. Positive times a negative, just throw that sign right there, okay? Then 3 times square root of 11 is just 3 square root of 11. We've distributed the first term, but hey, we got to go to the second term now. And we have to distribute the square root of 11 to 3 and to our negative square root of 11. So square root of 11 times 3, remember, this is inside the square root, this is outside the square root, so we can't combine them or anything. Remember, if this is under the square root and this is not under the square root, we can't combine them or anything. So we've got a positive times a positive, that's going to give us a positive right there. And then square root of 11 times 3 is just 3 square root of 11, because we can't combine them at all. One's under the square root, one isn't. Now we have our square root of 11 times square root of 11. But look, it's negative, right? So positive times a negative gives me that negative there. Then square root of 11 times square root of 11 is this guy. Look, we have the square root times the same thing. So that square root cancels, which is really nice. This is just going to give us 11. Now, do you see it? Do you see what happened in the denominator? Look, check it out. What's negative 3 square root of 11 plus 3 square root of 11? Well, those cancel, don't they? These are like terms. We have negative 3 square roots of 11 and then positive 3 square roots of 11. So those will cancel out, leaving us with, in our denominator, we've got a 9, and this just got canceled. So this minus 11 is still there. And then 6 minus 2 square root of 11 is, at this point, can't do anything else with that. So now we can combine these terms. 9 minus 11 is negative 2. And then at the top we have 6 minus 2 square root of 11. And right now you might be like, killed it. Oh man, got that right. But at the end, honestly, I should probably add this. At the end, you should check to see if you can simplify your solution, because actually we can do some more simplifying here. Look what we can factor out of the top. We have a 6 and we have a 2. We can divide 6 by 2 and 2 by 2. Therefore, we can factor out a 2. So a 2 would be on the outside, and 2 times what gets you 6? 3. 2 times what gets you negative 2 square root of 11? Well, you just factored out that 2. So this will be minus square root of 11. Then the bottom is still negative 2. Now check it. We have a 2 as a factor on the top and a 2 as a factor on the bottom. So we can divide the top and the bottom by 2, which gives us just everything in the parentheses here, 3 minus square root of 11 all over negative 1, because there's still a negative here. So really, we wouldn't leave it like that. We would go ahead and divide both of these terms by negative 1, so that we can have an expression without division, because we won't need it. If we divide something by negative 1, it just flips the sign. So this 3 becomes negative 3. Our negative square root of 11 becomes positive square root of 11. And this is our solution. And we can check our answer here. As we can see, here's our original expression, 2 over 3 plus square root of 11 right there. And here's our solution, negative 3 plus square root of 11. And once again, when we type those different expressions in, we get the same answer. Remember, we are just simplifying. We're not changing the value of the expression. We're just making sure that we have no square roots in the denominator. We're rationalizing the denominator. So for our last one here, this one ends up having 2 square roots in the denominator, but don't let that freak you out. It's the same idea. We want to multiply by the conjugate, okay? But we do want to go ahead and check to see if we can simplify anything in the denominator with the square roots, and we can't. That's step 1. Go ahead and check that, because really, if you can, it'll save you some effort later, but we don't have to worry about that. So we want to multiply by a clever form of 1. So remember, to find this clever form of 1, we want to be multiplying by the conjugate. If you remember up here, We said the conjugate is just when you take the two terms from the binomial, you keep those the same and you just flip-flop the sign in the middle. So we're going to keep the square root of 5 here, and we're going to keep the square root of 3. Those aren't changing at all. But what we do change is that negative. We're going to change the negative to a positive. So if we want to multiply the denominator by its conjugate, by the square root of 5 plus square root of 3, we can't just do it in the denominator because that changes the value of our expression. We need to multiply by a clever form of 1. So if we need this in the denominator, we totally need the same thing in the numerator so that it's just equal to 1. Because anything divided by itself is 1. Square root of 5 plus 3 divided by square root of 5 plus 3 is 1. Once again, make sure you distribute carefully. What I like to do here is add those parentheses. If you have any part of a numerator or a denominator that has more than one term, I personally just like adding those parentheses there to give you that visual reminder, hey, we're going to be distributing. So let's move down a little bit more again. We're distributing the 2 square root of 3 times the square root of 5 and times square root of 3. So in our numerator, we have 2 square root of 3 times square root of 5. The 2 is on the outside of the radical, so that's just going to stay on the outside of the radical. Our square root of 3, square root of 5, the 3 and the 5 are under the square root. So we leave those under the square root, and we will be multiplying those just as our property above states. Then we're going to do a positive times a positive here. That gives us a positive number. Then 2 square root of 3 times square root of 3. Hey, check it out. This works kind of nice for us. We have a 2 on the outside of the square root, so that's just going to stay there. But look, we have square root of 3 times square root of 3. Hey, look at that. That's just going to give us 3. Because remember, when we have a square root of something times the same square root of what's inside, we're going to get what's inside with no square root. It cancels. So that is our numerator. And then our denominator, remember, we have to distribute. We have to distribute square root of 5 to this square root of 5 and this square root of 3. So square root of 5 times square root of 5 is just 5. The square root of 5 times itself is square root of 5 squared. Cancels the square root, right? We're just left with 5. Square root of 5 times square root of 3, that's a positive times a positive, so we know this has to be positive. And then we have a 5 and a 3 under the square root, so that 5 and the 3 must stay in the square root. And they're factors, we're multiplying them. Now we need to distribute negative square root of 3 to the square root of 5 and to the positive square root of 3. Look, we have a negative times a positive. This is going to give us a negative term here. Square root of 3 times square root of 5 is the square root of 3 times 5. Remember, the 3 and the 5 are under the square root, so we leave them under the square root, multiply them. Then a negative times a positive gives us a negative, and the square root of 3 times square root of 3 cancels that square root, just leaves us with 3. So now let's take a look. What did multiplying by the conjugate do? 5 times 3, 15, right? 3 times 5, 15, okay? So we have positive square root of 15, negative square root of 15. These cancel. That is what the conjugate does. It ends up canceling out those terms in the middle so that we don't have any square roots anymore. So in our numerator, we want to go ahead and simplify. So we can't simplify anything there. 3 times 5, there's no extra factor that will give us a perfect square factor. So the top will just be 2 square root of 15 plus 6, because we have 2 times 3, that's 6, all divided by, these canceled like we talked about, but we still have the 5 and the minus 3, so that's going to give us a 2. 5 minus 3 is 2. Now notice, in the same way up here, you want to double check to see if you can simplify anything else. Well, check it. Every single term you can divide by 2, so we want to go ahead and do that. What's happening here is on the top, we can factor out a 2. So since we can divide this term by 2 and this term by 2, we can factor out a 2. Now, on the top, we have a factor of a 2 and a factor of a 2. We can divide 2 by 2, and that gets us a 1. So we are left with the square root of 15 plus 3, and that is our solution. So we could check it and we would see that this expression that we start with is equal to this one that we got. But I want to go a little bit more into like, why is the conjugate even helping us out here? What is so magical about it? Because it really is quite beautiful, isn't it? I mean, you must have seen it so far. Well, what's happening is we're utilizing the idea of a difference of squares. So if we know that a squared minus b squared factors like a plus b times a minus b, then these factors are equal to that, right? It works both ways. The equal sign means what's on the left is the same as what's on the right. Because we know that if you have a perfect square here, subtracted by a perfect square here, see that binomial there? If we start with something, this is kind of like a minus b. You see that? A minus b. You could just call square root of 5a, and you could call b square root of 3. So we're like, hey, if we could just square the square root of 5, that gets rid of the square root, right? If we could just square the square root of 3, that gets rid of the square root as well. So what do we need to multiply by so that we can square both terms? You see that? We just need the conjugate. If we have a minus b, we multiply by a plus b. This is the factors of a difference of squares. So when we distribute it, we have a difference of squares. And it allows us to square both of those terms. And as you saw before, even if just one of those terms has a square root, it takes care of it for us. Even if both of the terms have a square root, it takes care of it for us. So that's really nice, and we always want to keep this trick in our back pocket. So I hope you found this video helpful now that you have a better idea of why we're even able to use the conjugate to help us simplify radicals. If you found this helpful, make sure to subscribe. It really helps my channel grow, and I'm hoping to put out more videos like this to just help you all out with some math. Mr. Otwell out. Peace. And we can't simplify that anymore. So we're just getting this. God. I just missed the training I was supposed to host. Crap. Oh, it's at 2:40. Oh, I'm super late. But maybe, okay.